Hello everybody and welcome. Today we're going to be looking at AAA. No, not this kind of AAA. This is what we're looking at today. Authentication, authorization, and accounting. Now we've got lots of big fancy words here letting us all know the difference between authentication, authorization, and accounting, the three primary pillars of the AAA model. But this is what we're really here. Authentication. Who are you? Authorization, what can you do? Accounting, what have you done? So here's our topology set up for today. We've got a couple of different users, we've got a couple of different routers, and we have our Windows NPS or Network Policy Server setting up to do our radius authentication. Now, this is just a small, simple demonstration using the Windows NPS radius because it's free and it's very simple and quick to set up. However, if you're out there in the real world, you should absolutely look at a proper enterprise-grade radius server, and the two best ones out there at the moment that are pretty much neck and neck is the Cisco's ICE, Identity Services Engine, or the Aruba ClearPass. And Aruba's been bought out by Hewlett-Packard, so Hewlett-Packard ClearPass. These are both excellent AAA backend authentication servers. So we've got our Windows 2000 server set up, it's running Active Directory, and it's running our Network Policy Server. On the router, we have set up AAA. Now the absolute first thing you always must do is set up your local user database. You must have a local user database. It's not only there to fall back on, but it's also there for original setup configuration. Then we want to set up our authentication. So the command is AAA authentication, and we've got our login default group, and radius is the first entry in that group. The local user database is the second entry in that group, and just the enable secret password for the third entry. Now the most important thing about this AAA group setting is that it's in order on failure. So if the radius server is up and active and answering, the local user database will never be looked at because the radius server has to fail before we fail over to the next entry in the group. So if the radius server is active and you try and log in with the user admin and that user admin isn't on the radius server, it'll always fail. The only time your local user database is ever accessed is if the radius server is unavailable. So it's a backup. And we're also doing authorization. What can you do? And we're also pushing that out to the radius server because we're going to have a policy set up to say what you are in fact allowed to do. And then we've got the connection to the radius server as well. You need its IP address, you need a couple of port numbers, and you need a pre-shared key for security. And this pre-shared key has to match on the routers and on your radius server exactly the same. So inside Active Directory, we've got a bunch of users, Steve, Frank, and Bob, and we've created some Active Directory groups. So SSH admin is a group, and Steve's in that group. We've got the help desk group, and Frank's in that group, and just Bob's just in the default domain admins group. And here's the power of the radius. The Network Policy Server has policies. Our first policy is called admin users, and the policy states that if you are a member of SSH admins, will allow you to log in and will set your privilege level to the highest. Second policy is if you're one of the help desk users. If you remember the help desk security group, will allow you to log in, but your privileges will be to the lowest. And there's a default policy that doesn't have anything to do with router access. So when Bob tries to log in, you'll see what happens to him. So let's have a look at how this works in practice. Here we have our topology. We've got our radius server, we've got our router all set up with the AAA settings pointing at the radius server, and we've got Steve and Frank and Bob to test out their different access. So now I'm using Telnet because this is just a simple demonstration. Obviously in the real world, you would never use Telnet, you would use SSH, either PuTTY or Secure Shell or some sort of other program. So let's first log in as Steve. And there we are, we're logged in. We'll verify that we are definitely Steve. Yes, there we are, Steve. And now we're going to do show privilege. Now show privilege lets us know what access we have to the system. So we just logged in with username and password, and we've given level 15, which is the actual maximum on a Cisco switcher router. So let's log out now, and let's try exactly the same thing, but this time, let's log in as Frank. Oh, there we go. We've still got the privileged exec prompt, the hash symbol, but if we do show privilege now, we've only got a privilege level of 3. So Frank might think that he's a super user, can do anything, but if he tries to go configure terminal, error. That command doesn't exist at level 3 because it's a higher privilege level. We can still do things like show IP route or whatever we need to do, or show version, because they're fairly low level commands. But if we try and do show run or show some sort of higher privilege level command, that doesn't work because Frank's privilege level is only set to level 3. So Steve level 15, Frank level 3, all done by the Radius server. So let's now look at the Radius server to see how we actually make that happen. Here we have the Radius server, and I've opened up the network policy server console, and here are all our network policies. So the first one at the very top says policy for admin users. Here's my constraints or conditions. You have to be part of the admin's user group in Windows, and you have to be coming from this one IP address because it's in a lab environment. That could be a range or a subnet could go in there. And then we have this proprietary command. It's part of the Cisco proprietary commands, and it's shell, as in the console, privilege level equals 15. I'll actually go into it and show you what it looks like. So here's our policy overview. We've got 4 tabs. So the first thing we'll do is enable it. Obviously allow access or grant access. So the conditions, we've got a member of user group and coming from this one IP address. Obviously we can have a range there. Our constraints, don't worry about those for the time being. And under settings, this is what we actually push back. Well, the settings we push back. So we've gone in and we've got a proprietary Cisco setting called Cisco AV Pair, and the actual command we're pushing back is privilege level equals 15. So if we look at the help desk, exactly the same, except now we've got the help desk group and we've got privilege level 3. Now notice here that I'm using a different IP address. I've also got a third privilege level, a third policy that says either if you or help desk or admins, your privilege level 7 on a different router, customer number 2 router. So let's have a look at that in practice as well. So I'll exit out of here and we'll go to our second customer, see, customer 2, and now we'll type Steve. Now normally Steve would have a privilege level of 15, but now he's only got a privilege level of 7. Let's see what happens when Frank tries to log in. He's only got a privilege level of 7. Now remember, this is only happen at login. So if we went to change that policy, I'll change it now just to prove that it's easy to do. So we're going to change it now, and we're going to make the settings, and let's just for fun, oops, edit. Let's just change it to 5. So I've changed it to 5. Click OK, OK, OK. And now customer 2 privilege levels are all set to 5. Now his privilege level isn't going to change because we have to log out and log back in again. So we'll log out again and log back in again. And we'll try Steve. Level 5. So you can set up your policies. Policies with different IP addresses for the sources, subnets or individual IPs. And then you set up what privilege level people are going to get based on their user group, their Windows user group. Now remember in the beginning, I pointed out that you need to always have a default user, a local user database in case everything goes horribly wrong. So let's have a look what happens now when we do this. I'm going to disable, I'm going to basically just unplug the network cable on this server. So now it's no longer reachable. So we come back here to and we try and telnet. Now I'm going to type in Steve. and we're going to have to wait. So we're going to have to wait a bit because right now this router is desperately calling out to the Radius server saying, please, I've got someone I need to authenticate. What are we going to do? And the server's not there. So we have to wait until that operation actually fails before we move on to the next level, which is the local user database. And as you can see, it just, because there's no response at all, it thinks it's got a bad password. So we'll put in a bad password a couple of times just so it times out. Now, it's complete. It doesn't work. Actually, we'll prove. We'll put in the right password again just to prove that. All right, that's the right password for Steve, and it's still going to fail because the Radius server is no longer reachable. So what we'll do is we'll kill this connection altogether and start again, and this time we'll use the local user database. All right, so as you can see, the connection was lost. So we're going to go back in, but this time we know there's a local user database. And that was admin, the username admin that we created before. So as you can see, it tried the Radius server was completely unavailable, so it failed over to the second level, which was the local user database, and now we are logged in as the admin user. And because there's no server to tell it otherwise, and because we configured the local user database to have a privilege level of 15, we have that privilege level of 15. So let's go and let's log out and let's go and enable it again so that we can make sure that it works again after we've enabled it. Type in login as Frank, and straight away, because once the server's reachable again, then everything works. Now the only thing we haven't checked is good old Bob, because Bob doesn't have, there's no policy for Bob, because there's no actual policy to allow switch and router console access for everyone else. There's no policy for that. So there you have it. There's a really good example of how you can set up different privilege level and security access based on the IP address you're trying to authenticate against and the security group you're a member of. Now, one of the best features about our Radius server is you can use it for many different types of authentication. You can have it on your firewall, you can have it for your switches and routers, and you can have it for wireless. Now, I've done a couple of videos, long videos on wireless, so this is just a super overall summary. We've got the staff network, we've got the student network, we've got the guests. Now, in the good old days, you'd have 3 different actual wireless names in the air to join onto, but that is exceedingly inefficient. So what you do now is you have a single SSID, a single Wi-Fi name, and how you join that, what credentials you use, dictate what access you're going to have. So I've got, for the demonstration in a minute, we're going to use the Cisco Lightweight Access Point set up to a controller, but on some of my other videos, if you're interested, you can look at how we can do exactly the same thing with an Aruba virtual controller and with the Meraki cloud-based access point as well. Exactly the same. Different types of wireless setups, but all pointing to the same Radius server. So once again, we've got our 3 users, Steve, Frank, and Bob. But this time I've created new groups. So there's a Wi-Fi staff, and Steve's in that group. We have a Wi-Fi student, Frank's in that group, and of course Bob's just sitting there in domain users. So our first policy for the wireless is called wireless staff. And if you're a member of the wireless staff group, we're going to let you on the wireless network, and we're going to push back that you should live on VLAN 30. Our second policy, wireless students. If you're a member of the student group, we're going to allow you access, and we're going to push back that you should live on VLAN 40. And everyone else, who's just Bob or anyone else in the domain users, you're allowed to join the wireless network, and we'll let the wireless LAN controller actually figure out what VLAN you should be on. So let's have a look at that demonstration of how that's all put together. So let's fire up my iPad and actually try and join the wireless and see what happens. So Wi-Fi, So this is the one I created, network lunchbox C for Cisco, .1x, because we're using the authentication with both a username and a password. So we'll log in as Steve. Get to see my super secret password. Now, because I've just set this up, it's a dodgy certificate, all right? So in the real world, when you set up a wireless LAN controller correctly and you actually put a proper real world purchase certificate on it, you don't get this trust message. So we're joining the Wi-Fi now, and we've got a nice big tick, and we've got the internet connection. So let's see what IP address we got. Oh, .50, 192.168.50. But our policy says that we should be set up on VLAN 30. So there must be something we have overlooked. So actually I won't forget that. I'll just turn the Wi-Fi off. So let's have a look at our actual wireless LAN controller itself. Here's our wireless LAN controller. So let's go to the controller, check our interfaces. Yeah, we've got VLANs 30 and 40 and 50 all set up, ready to go. Let's look at the wireless setup. So here's our wireless network, Cisco network lunchbox, Cisco.1x. So it has a default VLAN, VLAN 50. So when you join this network, you should be on VLAN 50 by default, and that's what we want, but we want it to override. So under our security, we've got our AAA server all set up. So AAA is fine. Let's go and, here's our problem, advanced. Allow AAA override. So what's happening is that we're authenticating to our Radius server, and I'll show you that in a second. And it is pushing back the VLAN ID that we want, but the wireless is not accepting it. So let's go enable, and we go apply. We go okay. So now when we join the wireless, we should be put on the correct VLAN. So let's check that. So turn the wireless back on because I just turned it off. I couldn't be bothered logging out and logging back in again. I thought this would be faster. So it's automatically going to try and log in. And we've got our big green tick. We're going to information. There we are. We're on VLAN 30. So now you can see that we've actually joined the right network that we're trying to set up. So how's that actually working in the back end? Here's our VM console again. And here are our groups, our Wi-Fi groups that we set up. So we have staff access. Its conditions is, are you part of the staff network? And way down here, we've got a couple of proprietary tags. Now these are vendor non-specific as well. I chose the ones that are the most vendor non-specific because I've done this lab with Cisco Controller, Cisco Autonomous, Aruba Autonomous, and Meraki Cloud, and they all like this tunnel private group ID is a nice IEEE generic that everyone accepts. And here we are, we've set up for VLAN 30. So we're pushing back the number 30, and the wireless LAN controller says, oh, you want to be on VLAN 30? I'm going to put you on VLAN 30. Let's try a different user now and see what happens. So let's log in as Frank and see what network he gets put on. So we want Frank, and his super secret password. Join, and because we disconnected, we still have to trust the certificate every time. All right, now Frank is logging in, and let's see what network Frank ends up getting put on. All right, 40. So if you're a part of that student user group, you get pushed back to VLAN 40. If you're part of the staff user group, you get pushed back to VLAN 30. All information being pushed back from the Radius server. So let's forget this network again, and let's try Bob, the last one we haven't checked. Now Bob is just a member of domain users. And if we look at our VM console, you'll see that there is a default group down here. Whoops. And there's no tunnel ID. I haven't bothered to set. I haven't pushed back the VLAN. So we're going to be allowed access, but we're not going to force whatever VLAN. So we'll let the wireless LAN controller figure out what VLAN you're meant to be on. So now we'll log in as Bob and see what happens. Beep, boop, beep. Once again, we have to trust the certificate. Like I remind you, in the real world, you put a proper store-bought certificate on here, not a self-signed one, and everything will just work because that certificate is trusted by the device. So Bob is now authenticating to the Radius server back to Active Directory. And there we have it. So let's see what IP address he's got. And he's back on VLAN 50, which is the generic account for people who aren't specifically set up as staff, specifically set up as student. So I'll just quickly show you the policy. So we go into the policy, obviously we allow. The conditions are just a member of that group. We've got a fair bit of authentication stuff we have to mess around with, but here's the power of it all. We've added in tunnel private ID being the number of the VLAN we want you to be on. And these other two settings, they seem to be required as well, like a hybrid, a pairing. And let's look at the wireless LAN controller to see how that reflects on the wireless LAN controller itself. So I've brought up the wireless LAN controller again, and here you see the MAC address and the IP address, and if we scroll along a little bit, we see the actual username. So it's really, that's another excellent reason why you should use Aaa 2.1x in your, and a Radius server in your environment, because every time people log in, the actual name of the user logged in is actually logged. So you've got a full audit trail and you've got everything you need to know about that individual users. Now, just to recap as well, if I had multiple LAN controllers in multiple buildings, I would go into my policy and actually I could have a policy for staff access, and just like for the SSH, I could add the IP address, and that would be the IP address of where we're authenticating against, which wireless LAN controller or which access point. And that way, if you're in building 1, the policy can push VLAN whatever. If you're in building 2, the policy can push VLAN whatever you need to be in that building. Here's an example. So now you've seen this put into practice. And I just want to give you this quick example. We've got 3 buildings, but a single Radius server. So if you're in building 1 and you're joining the wireless in building 1, the wireless access point asks the Radius server for authentication, and when it's pushed back, it's going to give you the appropriate VLANs just for building 1 based on the IP address of the access point. So this gives you further granularity. So you don't have to have 3 different Radius servers for 3 different buildings, or 3 different campuses, or 3 different cities. If you've got your network all set up, you can have one big powerful TACACS Radius server controlling the AAA for all your wireless and all of your switches networks, all in a single location. Because we're not only looking for our username and password, but also we can check and write our policies based on the IP address of who's asking gets a different policy. All right, thanks very much for watching. Just a little bit of propaganda. My daughter has still got some sweet merchandise to help support my channel and support her as well. So if you enjoyed this video, please subscribe. A small click for you, but a large click for me. Click the notification bell for be notified when new videos are coming up. If you enjoyed this video, click the thumbs up, leave me a like, and add a comment with what you'd like me to make for my next video. Thanks very much, and I'll see you in the next one.